right, I have returned. So the task at hand before the break was to add template for day in and stream counter to stream plan so I can populate that in the stream manager. So I think we did that. Let's convert this to an issue. And we'll go over and let's just commit all this.
Me on the Charles River. I could die right now.
It's a lot of changes.
Just happier. I've never felt that before.
All right, well, we disabled mocks. Unless we want to turn them back on. We added stuff in stream info editor. Fixed some type issues, right? That was a big thing initially, is like stuff was just not loading. But yeah, so what issue number was that? 298. So create branch. Let's see what Copilot makes of this. Add stream title template functionality and enhance stream management components. Well, we don't need to say the second part. Fixes. Copy link. We are on the right branch, so oh, it's 297. No, I don't care enough. Just push it. It doesn't matter what the branch is called. All right. So we'll create the pull request, and I've kind of been enjoying. It's kind of, I mean, we're writing code. With the help of an AI with Copilot, but also having it, the Copilot bot in GitHub do a review is kind of nice too. It has surfaced a couple of things. I think it's definitely come up with things that are not issues or things that I want to, not address, but it's also, called out some things. Okay, so let's close all this for now. Let's switch back to main. Go ahead and click enable auto merge for whenever that happens. We do a hard refresh of this page to see that happening. There we go. So Copilot reviewed 5 out of 11 change files, generated no comment, so it just is like, yeah, I don't, it's fine. Looks good to me, Copilot says. All right, and that'll move over automatically, like so, which means I guess it, auto merged, all the checks passed. So what's next? Well, have Stream Manager bump stream counter when a plan is selected and stream is started. This is interesting to me right now because there isn't really. Oh, let's pull down main. There we go. We don't really necessarily select a plan, a series. With this UI, we do have one, the upcoming one, and we can copy its info to push to Twitch, right? We populate and then save. But I don't even have a start. Well, it doesn't make sense right now to have a start stream button because that happens in OBS. I think one of the things I do want to do is have, well, I will say in OBS right now, I do have a little dashboard. Most of the stuff doesn't work anymore. It's been broken for a while. But I do have a little Veet app that starts up when I start streaming. Show this. Yeah, there's nothing secret there. So it's just a little Veet app that I have an embedded browser So in OBS, you can create a custom browser doc, like so. Oh, you can't see that on stream because it's an OBS window. So of course you can't see it on stream. Well, anyway, you can create a custom browser doc and embed it in. And so that's kind of what I was thinking for some of this, is that some of this could be embedded inside of OBS, and that would allow it to actually interact directly with OBS, and tie in that way. But yeah, I don't know. So this is kind of me thinking out loud how this would even actually work, right? Because I would hate to have to be like, oh, okay, well, this says 100. Actually, that was the last stream was 100. Let me go back. Let me go into here, and let me change it to 101, and then save. Yeah. That would be suboptimal. Do I want to just add a button to the stream manager to like bump the number? Also, what's up with this? Snooze refresh. So like pre-roll, free time remaining. This I think is actually accurate. Is that number of snoozes is correct? Time until next ad, that's correct. It's a free time remaining divided by 60 seconds and a minute. 52 minutes? Yeah, that's accurate. It'd be nice if this was actually in like minutes. But yeah, so this information is right, but snooze refresh. This must be 0. Yes. That makes sense. Okay. Well, so maybe I don't want to work on this particular item right yet because I don't have a solid idea of how I would do that. So I'll just defer it for a little bit. Maybe something will occur to me. Let's do something completely different and work on some backend stuff instead. So how about some context? So inside of our infrastructure code today, we have this JSON file. Let me pull up AWS. That'll be good. There we go. So we have an API that the front end can call. Yeah, I think that's a good place to start. So let me pull up a couple of things and I'll just kind of walk through what's going on, what the problem is, and that will make sure that I understand the thing that I'm trying to solve myself. So in a stream, so like here is our stream record from December 1st. If I click edit, there's a button here that I've added recently called ingest videos. So many streams ago, we built an API and we were just kind of testing it by like directly invoking it. So I finally got around to adding a button. And the reason for that was that the ingest stream before, I forget how exactly it worked, but anyway, I wanted to make it so that we needed to do a couple of things, right? So let me take a step further back. So we have these records in this table, and it's called metadata table. It's not a great name. Naming things is hard, but this is basically the metadata about all of the individual video files from all of my streams. All, what was the estimate? 1,855. of them. And so there's the key. This is basically the location S3 where I've stored the file. And there's a bunch of metadata that is extracted or can be extracted from the videos in a couple of different ways. And so we have all this code. So there's some code that automatically is triggered when the file is uploaded to S3 now, although that wasn't always there. So the oldest videos don't have that. And so that's like the keyframes and metadata. So the metadata is like format information about the video file, the different audio and video streams inside, and what kind of codec it is, and all that sort of info. And then we have like silence detection. So any start and end points where there was silence for, multiple seconds. And then we have a summary and a transcription, or rather a transcription and a summary. So this is the part that the thing that I want to talk about does, right? So we have a location in S3 that has an audio file. So it has MKV on the end. It's not a Matryoshka video file. It's actually like a WAV or something, right? It just takes the original key and slaps audio slash onto the front. Whoops. Don't do that. And so I have this step function, right, called stream ingestion state machine. And it succeeded yesterday for the first time in quite a while. But if we look at its definition, it does a bunch of stuff. Okay, full screen does not work. Let's do this, and we'll zoom in. So it basically, what I can do is I can send it a prefix. So basically when I upload the video files, I organize them into where effectively folders. I put a prefix in front of the name that's based on the date. So when I invoke the step function, I pass in that prefix, and then I pass in the stream ID. So that's the primary key or partition key of the record in DynamoDB that corresponds to the stream that all the videos are associated to. So baked in to this is the assumption that I only do one stream a day, which has basically always been the case. If that were to change, I would need to do something different. But that's one of those things. That's a fine assumption, and it works just fine until it doesn't, and then we'd have to do something else. We don't. So what this state machine does is that it says, okay, well, let me take the prefix, go out to S3, list all of the files, all the objects with that prefix, and then it says for each one, it says, hey, do we have an item in DynamoDB for that record, which should be there for two reasons. One, we set up something so that when I drop a video file into S3, it automatically creates the DynamoDB record with all that metadata. And two, because I did say a minute or two ago that something that kind of was introduced midstream, right? I was uploading stuff to S3 to archive it before I implemented the code to put stuff in Dynamo. But what we did a couple of streams ago was I implemented a data migration, because I also had a bunch of metadata in a Postgres database running locally. So I created stuff in Dynamo for that. So a lot of the records in S3 now have records in Dynamo. So it'll find that, it will check, hey, do we have a transcription? If it doesn't, and it says, hey, do we have the audio? Did we do the original ingestion process? If the audio doesn't exist, it triggers that ingestion process. So it's just assuming that, oh, I guess the process didn't get run. Like this video file maybe predates, or maybe there was an issue, so it didn't get run. So it runs it, it waits for it, and then either way, it transcribes the audio from the video file into text. And that task stores the text back in DynamoDB, and so we just return back and we re-get the item, and then we continue through. And at this point, the transcription would exist. So then we use OpenAI's API to summarize the transcription. So we send it a prompt and we send it the text of the video and some context that we've accumulated as we're processing all the videos in series for the stream. And we say, hey, give that back to us as JSON, and we use that JSON to then update the DynamoDB record. And then the last thing we do is we have the stream ID that's passed into this whole state machine. So we store the stream ID in the record in Dynamo, right? So here, like this record was ingested through this process because it was the last stream that I tested this on. Or rather, this is one of the video file, the metadata of one of the video files for the stream, right? So it added the stream ID. That's super important because in the app, we want to be able to do things where we're like, hey, I want all of the transcription information from the stream. So I have an API endpoint where I can say, hey, here's the stream ID. Find all the video clips. That's another name I use for the records in this table. That have the stream ID. So, and I think we set up some of that on stream because I remember us doing, setting up a global secondary index for this. Yeah, we did this and we did the API stuff on stream. So we have an API, and the API, we also implemented quite a while ago, but we hadn't tested from the app. It integrates to our step function, right? So, I think I have to maybe click edit to see that. Yeah, step function, role, mapping templates. Oh yeah, it's inside of here, right? So we have the ARN of the step function that we want to run, and we can pass through the inputs. So this allows the front end to be able to call that API, which is behind authentication, that we've also set up, by setting up logins with Cognito and using Cognito auth to get a access token to be able to call through to the API. So that's what this button does. This is essentially starting the step function and making sure that all the data is present, and then summarizing all of the what happens in the stream. Okay, so I had a point in explaining all of that. Oh, right. So an issue that occurred, especially where I had I don't think it was necessarily even the fact that I had to stop and restart things. No. I think it's just if I have a stream and has a bunch of video clips in it. Hey,
Silo_13K just followed.
Thanks for the follow. If I have a bunch of video files, like there's gonna be like 10 video files per stream, right? Because these are like 20-minute segments, and I usually stream for like 3 hours. In like, I do an hour, take a break for a couple of minutes, do another hour, that sort of thing. So it's a lot of calls, it's a lot of tokens, it's a lot of activity to the OpenAI API. And so I wanted to do some rate limiting. Right, okay, so that was the task, was we want to rate limit these calls, right? So we want to say, hey, well, we need to figure out how to do that. So I guess one thing I could do is I could look at when we had the failure and what it told us. So the let's take a look. Was it the supported one? It couldn't have been the supported one, could it? Yeah, confirm. Did we have a failure and we just kind of recovered from it? I definitely saw I think this one was the one where we got the yeah. Um where we got the error, and then I used the retry functionality to basically resume the function, the step function where it failed, and just it restarted that task and then continued on, because it was just like a temporary relimiting. You can imagine if I had like 5 different streams and I was trying to like ingest them all, then I might had some harder rate limits on things. So this is essentially like probably what we need to do, and we'll look at the docs for OpenAI in a second. Probably what I need to do is I need to look at what the response is, and I need to do some kind of error handling here that is either going to like wait some time and then retry, or it's going to bail out of the step function and say, hey, you've exceeded your limits for the month, and pay OpenAI more money or something. I don't know. We'll see. So somewhere in here, there should have been a failure. There we go. Task failed. So this is the summarized transcription task. So that's a Lambda function that I wrote on stream. It seems like forever ago. And this is not super helpful. So we don't actually get a lot of detail about the error. The Lambda panicked. We probably want to make the Lambda return a better error that tells us the nature of the problem, so that the step function can then use that information to do something. Especially like for a Lambda that can only run for a maximum of 15 minutes. You can imagine if you have a rate limit issue, what are you going to do? You're going to wait in the Lambda? That could potentially be a problem. Whereas the step function, the nice thing about the step functions in AWS is that these things, this kind, the kind of the default kind of step function, I forget what it's called, they can run for like a year, right? So you can have really long running tasks, like workflow tasks that are like, send someone a call and wait for someone to click a thing, and a record exists in something, manual intervention type things. You could do that with this. But anyway, so we can go look at the log group in Lambda to see what the error was. If we can find, this was at 14:44 yesterday. Yep. I was working on this on Christmas. 14, maybe this log group or log stream. We had a lot of activity. There it is. So, I think at some point when I was coding this Lambda, I basically said that I was going to be fine with panics. And this is why I would not want to be fine with panics, because we want to actually provide structured errors back to the step function. So you can see rate limit reached for GPT-4o in my org. So I have a limit of 30,000 tokens per minute, and I used 28,872, and I requested another 4,854. Excuse me. Also, let's make this bigger. Let's get rid of the sidebar. Maybe you can actually read it along with me. There we go. Talking about this right here. Oh, except it scrolls. Right. So we want to probably visit this page to learn more. So we can see there is some structure in the error that we're getting back from the API, where it's like, here's a message. It's all of that. There's a type, tokens, and there's a code rate limit exceeded. So I'm going to guess what we're going to need to do is do something where we inspect the error and return some kind of information back from the Lambda. So let's go look at this documentation. Rate limits. Yeah, and there's different rate limits. So there's much higher limits if we were using GPT 4o Mini or 3.5 Turbo. We have usage limits. Interesting. Here's a rate limits guide. Okay, this is what I was actually expecting when I followed the link. Okay, rate limits are measured in 5 ways: requests per minute, requests per day, tokens per minute, so TPM is what we hit. If we hit like requests per day or tokens per day, that's where we potentially I don't know. We could even not bail out of the step function, but just have a wait a day. I don't know. I'd have to think about that. It's like usage tier stuff. So like tier 1, rate limits. In addition to seeing your rate limit on your account page, you can also view important information about your rate limit, such as remaining requests, in the header of the HTTP response. So this would be a way where we so I think there's, broadly speaking, 2 ways to address kind of the rate limit situation. Both are going to be dependent on me making information available in the from the Lambda back to the step function. But then we can either wait until we get a failure that's based on the rate limit, and then wait some period of time and hopefully set that wait based on the information we get back. Or we always get information about the rate limit from the Lambda, from summarized transcription, and then based on those headers, we wait some amount of time, right? So we have X rate limit, limit requests, maximum number of requests that are permitted before exhausting the rate limit, limit tokens, maximum number of tokens that are permitted before exhausting the rate limit, remaining number of requests that are permitted before exhausting the rate limit. So lots of different things here, right? Based on, because there's like request-based limits and token-based limits. Time until the rate limit based on requests resets to its initial state. Time until the rate limit based on tokens resets to its initial state. And then there's a section on error mitigation. Okay. One easy way to avoid rate limiting errors is to automatically retry requests with random exponential backoff. Yes. Could do that. Yes. Yes. So this approach, it would be a third way. Instead of looking at any of the information about like usage or time until we get more usage or any of that stuff, we just try again. Wait a little bit of time, try again. If it fails again, we wait longer, and the kind of the growth of the amount of time we wait as we continue to fail goes exponentially, right? And we also throw in some random jitter, right? So that we don't end up in a situation where, like, if we have multiple processes going at the same time, and they are all retrying, and they have a deterministic amount of time before they try again, you end up with this. You can end up in a situation which is described as thundering herd, where you have like a bunch of things that are all trying to hit a service, an endpoint API, and sure, they're doing exponential backoff, but maybe they were all triggered roughly at the same time, and so they all retry at the same time every time, and so then all of most of them fail because they exhaust resources really quickly. So anyway, reduce the max tokens to match the size of your completions. Batching requests. So there's a batch API. Ooh. What about a batch API call? That is effectively what we're trying to do here. 24-hour turnaround time. What does this look like? So we upload a JSON. I don't know that I've seen it called the JSON-L file before, but it's a line-based JSON. Yeah, okay. So it's like every line is a JSON object. Yes. Okay. So we create a batch, and we get some information about the creation of the batches, and then we can check the status. So that's interesting. I think I don't necessarily want to do this. I think at scale, this might be a really good thing to do. I mean, the approach that I'm taking here of like having the step function and kind of batch processing things, it might really make sense to do something like that. How would I do that? How would I approach doing that? I guess what I could do. I don't think that's necessarily worth pursuing at the moment. I think maybe let's add exponential backoff. Now, one thing I do want to do is I don't want to do exponential backoff if the error. Well, let's think about this. Are there cases where if summarized transcription fails, I want to just give up? Because I think for right now, I would like to say if there is issue with rate limit, then we can do exponential backoff with jitter, and then otherwise we don't. Something like that, right? So that's a lot of talking and thinking and reading. Let's read something else. Specifically, we have a Lambda function, summarize transcription. You look at some Rust code. Just ignore the yellow squigglies. Okay, so we have a main, and that's the kind of the Lambda runtime invocation stuff. And we have a handler, and the handler does some things, right? So it tries to get the transcript from DynamoDB. Rather, right, I see. So we get the transcript from the step function, that's passed in as the event to the Lambda, but it's formatted as if because it's coming from DynamoDB, and we're not unpacking it in the step function. So we're deserializing that, and then we're getting our secret for the OpenAPI or the OpenAI API from Secrets Manager. That's what's going on here. And then we're using the OpenAI Dive crate, Rust crate, to interface with the API, and then we're doing stuff. We're like passing in our instructions and passing in the transcripts and context, and then we're getting a response. And so here is where we are probably failing, when we try to create and then wait and expect, I think, right? Because then we're just parsing the result. So let's check that assumption. So if we go back here, we go back to executions, and we find where we failed. Yeah. If you're wondering about that pop-up, it's because well, the immediate cause is that there is a lot of state information in the execution history. But the reason for that is because in a lot of places, like I'm getting the item from Dynamo, I think is not so much the issue. But no, it is. Yeah, it's things like this. There's a lot of information, and I think I'm maybe not doing the best job of cleaning up the state. Or maybe it's just because of all the state transitions, in each one there's like a copy of that data. But regardless, there's just a lot of information. It's like giving me a warning that the UI might be slow because there's so much state, unless I want to not load the details, but I do. All right, where was that failure? Was that on page 2? No. Was it? Here it is. Task failed. Oh, right. And we don't really see much of anything here. We need to look at the log. And this is where we see failed to call OpenAI API, rate limit error. Which is this. So, if nothing else, a demonstration of why every time you're handling an error, you want a different error message. Something to distinguish, right? Imagine if these all were like expect, and then the message was just API, OpenAI failure or something. Then I wouldn't be able to know which thing. Okay, so what else do we know about this situation? So currently, we say that we give a result, and it's either a response or an error. This is a Lambda Runtime API Client box error. What's that all about? Interesting. This is coming from Tower, huh? So this is the Lambda runtime crate. Okay, so this is also using Lambda runtime error. Okay. Do I want to try to have it return an error and then try to deal with that? So going back to here, so we have resource type lambda, resource invoke, error is thing. My concern is going to be that if I, like, there's nothing about the actual, panic set values error with panic message, including the, I mean, really, do we even, why are we panicking, right? This is a result. So none of this is really, like, this should be something like, what is it? Okay, or else error. Right, so then we repackage this option as a result, and then the question mark means that we, if it's an okay, that ends up in here, and if it's an error, then we return the error, right? And that should be valid. So we could be doing that everywhere, right? Except expected FN once closure found result. Huh. I'm doing something wrong here. Okay, or else. Oh, okay. So this is supposed to be. It's supposed to be okay, or that's the thing, right? Transforms option T into result TE. T. Okay. So, but this is not compatible, right? Because this error isn't compatible with this error. Let me go find the docs for, let's see, crates.io, Lambda runtime. Do you have an example? Do you have an example of returning an error? Yeah. This. Ooh, if your function returns lambda runtime error, the error type will be something like, yeah, it's not very descriptive. To get more descriptive error type fields, you can implement from for your error type. This gives you full control of what the error type is. Excellent. This is exactly what I'm after. All right, so let's see. Up here somewhere we do like, here's the request and response structs. We'll have an error response. Let's do something where we do this. So we have like type and message. Then do this. This is okay? Okay. All right, I haven't finished the thought here. So the example is we can give an error with error response. And we can say we can give a code, right? It's a secret not found, and the description secret not found. That could be a thing. Question mark. There you go. Okay. So, still doesn't like it. So the handler is supposed to, right? Okay, there we go. Bam. Come on now. Convert the error to error response. Conversion error value from trait. Okay. Error result. Error response. Error response. What have I done wrong? Oh, right. These errors here. Let's import. That'd be why. Okay. Still don't like it. Following other types, implement trait from residual. Let me look at the full compiler diagnostic. Brainless. Lucky 13.
Brainless Society just subscribed for 13 months.
Thanks for the
12
resell.
plus 1.
Thank you for being here. But why is this not working? Howdy indeed. Happy Thursday. Couldn't convert the error to error response, but it is error response. Maybe it's not supposed to be wrapped in an error like that. Oh, there we go. So maybe I should read what OKOR does. OKOR 0 gives error 0. All right. So, doing this, I should be able to see the details of the error, and they will be relevant details in the step function, assuming I have to take the rest of the things in the handler, so that I can take action based on what kind of error it is. So this is good. So let's continue this, and maybe, okay, that's too much to ask for. OKOR, invalid transcription, that could be an error. Let's also handle failed to get secret. OKOR. Hey!
The audience just followed.
Tutius, maybe? Thanks for the follow. Welcome on in. Okay. I missed a dot. Oh, this is a result. Okay, so what we need to do... let's see, how do we take a result and then say... Is it or else? Calls OP. Okay, so this is gonna call a closure if the result is error. Otherwise, it returns to a k value of self. So just or is probably a thing. Is that valid? Yeah. Okay. And this is a result, so this also needs to be an or. Oh, okay. So in OKOR, it automatically wraps it in a if you will. Okay, so that Seems fine. So basically, if the call to secrets manager fails, I guess I'll say that it's secret not found. I think that I guess that could be true. It could be true that we tried to retrieve the secret and it just doesn't exist at all, or we tried to get the secret string and it's not set yet. And both of those can represent the secret not being found. Okay, so I'm gonna go through every place where we're calling .expect that would cause a panic, and I'm gonna make it do error handling instead. So, this is like that. It could be a little bit more verbose. There we go for the description. And then we have another expect here. Or yeah, so now we're taking the transcript and the summarization we got from the input, and we're trying to packaging it up as JSON. Input for, yeah, sure. Okay. Let's keep on marching on. So we have something where we're failing to build the chat parameter. Yeah, I think these are all kind of the same issue. We do want the message to be slightly different for reasons that I mentioned before. Cannot build parameters. Yeah. Then this represents us failing to call. It could be interesting here to do something where we are, well, we wanted to surface something where we're getting a, that we want to handle the kind of error that it is. So I think what we'll do is we'll take a step back here. We'll do a wait, and then we'll say match the result. So if we get a response, an okay, then we do that. And then we want to look at what the error is. There we go. So what we want to do is we want to, so we have an API error type here. Can we do something like this? Yeah, that could be good. You do something like that if I wanted to be less ambiguous. But can I just do I don't think I want all these different cases. Can I just do underscore? There's underscore. And then some other, something like that. I probably have to import. Yeah, there we go. All right. And then we need to borrow message. Can we borrow message? No. Let's clone. Expected. Okay, so 2 str or 2 string. No. Someday I'm gonna remember all the different ways to manipulate strings like this. Okay, well somehow it's been another hour. So I'm gonna take a break here for a couple of minutes. Stretch my legs, and then we'll come back and we'll continue working on this Lambda function. Dealing with the remaining, it looks like that we have a couple more places where the Lambda can panic. Adding proper error reporting. And then we'll look at how we can handle that in the step function and do different things, including exponential backoff retries. So be back in just a few minutes.